Okay, so what we're going to do in this first lesson is going to actually look at identifying the sides of a right angled triangle and rewriting Pythagoras' theorem using this. So let's have a look at the first example. Example number 1. I want to rewrite Pythagoras' theorem for this triangle over here. Okay, so I've got a triangle here, and instead of having A, B, and C, I've got 3 different letters, P, Q, and R. What I want to do is be able to rewrite Pythagoras' theorem for this triangle over here using P, Q, and R. Now, when I'm doing this, the first side that I'm going to look at first is going to be the hypotenuse. So let's identify what the hypotenuse is. The hypotenuse is the longest side of my right angle triangle, and it's opposite the right angle. So what I'm going to do is I'm going to look at my right angle. I'm going to go opposite it, and I'm going to look at that slanted side. What's that side length there? That one's just R. So here, I'm going to write Pythagoras' theorem like we had above. Instead of writing it in the first way, I'm going to actually write it in the second way. I'm going to go C squared is equal to A squared plus B squared. Okay. Now for this triangle, right angle triangle here, I know that the value of C, or the hypotenuse, is just R. So I'm going to write R squared instead of C squared. So here, the hypotenuse is just R. So let me I'll label both of these. So hypotenuse for the triangle. So I've got R squared. R squared is equal to, well, what's A and B? A and B are the lengths of the 2 shorter sides. As I said before, it doesn't matter which one is A and which one is B. As long as they're the 2 shorter lengths of my right angle triangle, that's all that matters here. So I'll just call P A and Q B. So I'm going to go, instead of writing A squared, I'm going to write P squared plus, instead of writing B squared, I'm going to write Q squared. So for my triangle here, my right angle triangle here, this is what Pythagoras' theorem tells me. If I square R, that's going to give me P squared plus Q squared. That's all you need to do for this part. When you're writing Pythagoras' theorem for a certain triangle, you need to identify what's the hypotenuse. Where's the longest side? It's directly opposite the right angle at any given time. And then I square that, and that's going to be equal to the square of the 2 shorter sides added together. Okay, so that's this first example, and that's in your booklet that you would have received. Now, along with this, we're going to have a look at this second example. In this second example, what we're going to be doing is we're going to be substituting values into Pythagoras' theorem. So I'm going to substitute the numbers into this of the triangle here. So I've got a triangle and the side lengths are 6, 8, and 10. I want to substitute that into my equation A squared plus B squared is equal to C squared. What I'm going to write is I'm going to start off by writing this equation. A squared plus B squared is equal to C squared. Okay, I've written my equation here. What do I need to do? Well, I just need to figure out what A, B, and C are. Let's have a look. As I said before, I'm going to start off by finding the hypotenuse. The hypotenuse is just the longest side of my right angle triangle. It's the one that's slanted. And it's also the one side that is directly opposite my right angle. So let's have a look at my triangle here. My right angle is over here. Directly opposite it is this side over there. And it's the slanted side, so it's the longest side. So my value for C here, I'm going to start with C. It's just going to equal to 10. So for my equation below, I'm just going to write, instead of writing C squared, I'm just going to write 10 squared. 10 squared. Okay, cool. Now that I've done that, I'm going to identify A and B. And as I said before, it doesn't matter which one is A and which one is B. As long as A and B are my 2 shorter sides, that's all I really care about. So here I'm going to write 6 as my A and B as my 8. So I'm going to go A is equal to 6 and B is equal to 8. You can have it the other way around. You could totally write A is equal to 8 and B is equal to 6. That's fine. Still going to give you the same thing. Here I'm just going to keep it like a little bit of order. I'm going to write as 6 and 8. So here, all I'm going to do, instead of writing A squared, I'm going to write what's the value of A? A is just 6. So I've got 6 squared plus 8 squared. And so here we go. For my triangle over here, I've substituted my values in. Now, because we're dealing with numbers here instead of letter in pronumerals, you can actually check whether or not this is correct. you can check the left-hand side, and if the left-hand side of my equation is equal to the right-hand side, I know that this equation is correct. So let's just check that. So on the left-hand side, I actually have 6 squared plus 8 squared. So here we go. I'm going to copy that. We'll put that underneath here. I'm going to just check. Oop, and hasn't worked out. That's okay. I've got this over here. I'm just going to put that down over at the bottom over here if I decide to work. Oop. There we go. Okay. So I've got 6 squared plus 8 squared. Now, if you put this in your calculator, I'm going to put this in my calculator. I've got 6 squared plus 8 squared. I'm putting it in, and that'll give me 100. Okay, cool. Now I can just check the other side. I've got 10 squared on the other side. Pen's not working, but that's okay. 10 squared on the other side. What's 10 squared? 10 times 10 is 100. So here, this equation works. So we know Pythagoras' theorem works for this triangle over here, and we know it's a right angle triangle. So have a go at a few of the questions for me in this chapter, and I will see you in the next video. Bye.